Hi there, welcome to my channel Mandu to Fundu. In this video, I am going to discuss about the solution for finding the longest common prefix among these set of strings. Let's look at the problem description. We are given a set of strings and we have to find the longest common prefix among them. And if there is no common prefix, we have to return an empty string. Take a look at the example 1. Here we have flower, flow, flight. So the common prefix is FL. And in the case of example 2, we have dog, race car, car. But there is no common prefix, so we have to return empty string. So the array length is ranging from 1 to 200 and the individual strings length will be 0 to 200. The string contains only lowercase English letters. Let's look at the approach to solve this problem. So we have an input array of strings, flower, flow, flight. Output as prefix will be FL. Okay, so the brute force approach is first we take the length of the first string and traverse the entire array count number of times, and on each iteration we compare the corresponding letters in all the strings. If all of them are matching, then we add that ith character in the prefix. Then finally we return the prefix. The time complexity is order of m times n, where m is the length of the first string and n is the number of strings in the array. So this remains, the complexity remains same regardless of the nature of the input, or the base case and worst case, average case, all the cases it is order of m times n. Second approach is window resizing approach. We first initialize the first string as a prefix and then we traverse the rest of the strings in the input array and then check whether the current string has that prefix in it. If so, we will keep that prefix as it is. Otherwise, we will keep updating the prefix size. Okay, and finally when we come out of the traversal, we will be having either the longest common prefix or an empty string. Let's look at the flow chart. The input for this procedure is an array of strings. First we initialize the prefix. Basically, prefix will be initialized. Then we check whether we processed all the elements in the array. If not, we check whether the prefix length is greater than the current string's length. If so, we have to adjust the prefix length because the current string definitely cannot have a prefix which is more than its length. So we have to trim the prefix to the current string size. So basically we are trying to find the longest common prefix, so we have to adjust the prefix to the current string's length. Otherwise we simply check whether the prefix length is greater than 0 and the current string do not have the current prefix in it. So in that case we repeatedly reduce the prefix size by 1 character and then we attempt to find that the new prefix is present in the current string. We keep doing that until we exhaust the prefix or the current string has that prefix. So in either case we come out of that condition and then we check whether the prefix length is equal to 0. That means there is no common prefix. So we simply return the empty string. Otherwise, we repeatedly use that current prefix for the further processing. At the end, we return the prefix. Let's move on to coding. First, I initialize the prefix variable with the first string in the input array, and then I enter the for loop, and this for loop process the element from index 1 to the end of the array. So inside the for loop, first I check whether the length of the prefix is greater than the length of the current string. In that case, we have to trim the prefix string because the longest common prefix cannot exceed the length of any strings in the input array. Then next I check whether the given prefix is present in the current string as a prefix. If it is not present, then I reduce the prefix size by 1. Basically, I remove the last character in the prefix and check whether the new prefix is present in the current string repeatedly until the prefix will become empty or there exists a prefix in the current input string. I'm removing the last character in the prefix. Then after this loop, I check whether the prefix is empty string. In that case, we do not have longest common prefix. I break out of the loop, and then finally I return the prefix. Next, I'm going to run the test cases. Okay, all the tests passed. Next, I'm going to submit this program. Cool, this program is accepted. Next, I'm going to do the code walkthrough with sample input. So we have this input array which has 3 strings, flower, flow, and flight, and the expected prefix is fl. Okay, so when we enter this function, first we initialize the prefix variable with the first string. So in the outer loop iteration 0, the prefix is initialized with flower and the current string, and then next we traverse the rest of the strings in the input array starting from index 1. So the 0th iteration, the index value will be 1, pointing to the element 1, which is flow. Okay, so the prefix is flower, current string is flow. Inside the for loop, we check whether the prefix length is greater than the current string length. So the prefix should be less than or equal to the current string length, right? So for that reason, we reduce the prefix size to make it equal to the current string length. So that's what we are doing here. So when we at the end of that iteration 0, both prefix and current string will be same. Okay, and in the next iteration, the idx point to the word flight. Okay, so the prefix is flow, the current string is flight. So we are checking whether the length of the prefix is greater than the length of current string, but it is not true. So we are checking the next condition. We are entering the inner for loop. Here what we are doing is we keep reducing the prefix size until we find that prefix in the current string. Okay, so that's what we are doing here. So right now, when we enter the inner for loop, in the first iteration the prefix is flow and the current string is flight. Okay, so the flow, the current string do not have this prefix in it, and also the length of the prefix is greater than 0, so we reduce that prefix size by one character, so it will become FLO at the end of iteration 0 in the inner loop. And then we check in the next iteration of the inner loop, we check whether the flow is present in the flight. If not, it is not present, so again we are hitting this condition, we reduce that size and it will become FL, the prefix become FL. And then I think in the third iteration we let me make it okay. So here we check whether the length of prefix is greater than the current string, it is not, so we check whether the length of prefix is greater than 0, it is true, but it does have the prefix FL in flight, so we are not hitting this condition, so we are not entering the for loop anymore. Then we come out and check whether the prefix length is 0, in this case it is 2, so we continue the next element, and because there are no other strings in the input array, we come out and return the prefix FL. Next I'm going to do the time and space complexity analysis for this solution. Okay, let's do the time complexity analysis for this input. For the case 1, all the input strings are of same length and they are all having the same prefix, so the output will be 3. So in this scenario, let's see how many times this outer loop runs and then the inner loop runs. Okay, so first in the first iteration we compare this string with this, so we make a call to the hash prefix which will check whether both this prefix is present in this by comparing the individual characters, so which runs 3 times. So on the 0th iteration we do that 3 times, and then on the first iteration again for this ABC we compare, check that whether it has a prefix, yes it is, so then after that we come out and we return that prefix whatever is in the first string. So in this case the total number of comparisons is, on each iteration we do 3 times, so it will be 2 times 3, which is 1 less than the total number of element and then the size of the string, length of the string. So in that case the time complexity will be n minus 1 times n, so it's approximately n times m, where n is the number of strings in the slice and m is the length of the individual string. Okay, and let's see the time complexity for the case 2, where none of the string has a common prefix, so in this case the output is empty string. So in this case we compare the hash prefix, it the compare the character by character, so the first character comparison itself is failing, so we do only one comparison in each call. So on iteration 0 one comparison, on iteration 2 one comparison, so the total number of comparison will be 2 times 1, which is n minus 1 times 1. So in this case the time complexity is order of n, n is the number of strings. In case 3 we have a common prefix, the length of each strings are not same in the input. Okay, so in this case on the first iteration we first we initialize the flower as the prefix, then we in the first iteration we compare 4 times and found first we yeah 4 times and we found this prefix is present. So that's why on the 0th iteration of the outer loop, 4 comparison. On the first iteration, next we check whether the flight has the prefix flow. So in that case, we will be entering the inner loop. Okay, so first we have flow and we are entering and we compare with the flight, and flight do not have a prefix flow, so we reduce the prefix to. So when that call we did a 4 comparison, and then the next time we check we reduce this flow, we remove the W out of the prefix, and then we check whether the FLO is present in the flight, and that is also not there. So for that we do the 3 comparison. Okay, and then we reduce the string size, prefix size, and again check whether the string of length 2 is present in the current string. So we do 2 comparison. So total is 17 here. Is also approximately 3 times 5 equal to n times m. So this time complexity for this case is n order of n times m. And with respect to the space complexity, we do not allocate any additional space and we just use only the prefix variable. So the space complexity is order of 1 for this procedure. Thanks for watching this video. Have a great day.